Hi guys, so this video is the next video in our stoichiometry notes. We are going to learn about limiting reactant. We're not really learning anything new, we're just taking what we learned last class and adding one more step to it. So once again, you're definitely going to want a calculator and a periodic table to solve these problems. All right, let's dive in. Okay, so like I said, we're not really doing anything new here. We're solving these problems the same way. The only thing is we're doing more of the same type of problems, essentially. Okay, so how do we set up limiting reactant problems? Very similarly to how we do normal stoichiometry. So as always, we start with a balanced equation. And then the only difference is you're going to be given multiple givens in the problem. So you'll set them up separately for a dimensional analysis problem. So what I like to say is if you have two givens, that means you are doing two problems. So if you're given three givens, you're going to do three problems. Just like in the past, we'll convert to moles, use our mole-to-mole ratio, convert to what it's asked for. And then our last step that's a little different is we are going to compare our answers. And we always pick the smaller of the two answers. Basically, we're trying to figure out how much can we make if we're given this much. And so the smaller answer is always going to be correct. So we are going to start with a kind of real world example that'll hopefully help you guys understand a little bit better. And then we'll jump into doing this with actual chemicals. All right, so molecule, get it? Okay, wants to prepare pizzas for herself and her friends. She knows she needs 23 pepperonis per pizza. If Molly has a package of 157 pepperonis and 9 pizza crusts, how many pepperoni pizzas can she prepare? All right, so step one of any stoichiometry is a balanced chemical equation. Now here, this is a little bit of a different equation. Obviously, we're not using real chemicals, but it does give it to us in our problem. So we can assume we're going to be talking about crusts and pepperonis from our problem. So we know that for one crust, she needs 23 pepperonis, and that will make one pizza. Okay, so there's our balanced chemical equation. One crust plus 23 pepperonis makes one pizza. Obviously not a real chemical reaction there. All right, now Molly has 157 pepperonis and 9 pizza crusts. So we need to figure out how many pizzas she can make. So we're gonna start with our givens. And we have two givens, 157 pepperonis, 9 pizza crusts. So we're gonna take each of those separately. So I'm gonna start with 157 pepperonis. All right. According to our balanced chemical equation, it takes 23 pepperonis to make one pizza. All right, and we go ahead and solve that one. So 23 pepperonis to make one pizza. So 157 divided by 23 gives us that she can make 6.8 pizzas. Obviously, this is pizza, so we're going to round to a whole number, but the lower one. So she can make 6 pizzas with that amount of pepperoni. All right, now let's look at our crust. So for every 9, she has 9 crusts. One crust makes one pizza. So based on the number of crusts she has, she can make 9 pizzas. All right, so based on those two things, how many can she actually make? She can only make 6 pizzas because she runs out of pepperoni. So therefore, pepperoni would be our limiting reactant, and crust would be our excess reactant. So let's go ahead and kind of define those. I'm going to zoom in really small and just write my definitions really small. So the limiting reactant is the reactant that limits how much we can make. It limits the amount of product produced. So our limiting reactant is the reactant that limits the amount of product we can make. All right, and our excess reactant is the reactant that we have extra of, that has excess or some left over at the end. So our limiting reactant is the one that limits how much product we can make. Our excess reactant is some that is like we still have some left over. So for example, here we still had 3 pizza crusts because we could have made 9 based on our crusts, but we were only able to make 6 because of our pepperoni. So we had extra or excess crusts at the end. Okay, so that's with pizza, which is pretty easy because we don't really have to think very much. So now let's do it with chemicals and chemistry. All right, we're going to start with a nice, easy mole-to-mole ratio one. So this one says an amount of 6 moles of BlCa2 are placed in 5 moles of H2SO4. How many moles of product will be formed? It just says product, so we can choose either one. I'm going to go ahead and say, let's go ahead and change it to how many moles of HCl, or hydrochloric acid, will be formed. All right, so we're going to solve this the same way we've solved our other ones, except for we have 2 givens, so we have 2 stoichiometries. So I'm going to start with my first given, which is 6 moles of BaCl2. So I have 6.0 moles of BaCl2. I'm already in moles, so my next step is the mole-to-mole ratio. So I don't want moles of BaCl2, so I'm going to drop it low. And then I'm going to do my mole-to-mole ratio. So for every 1 mole of BaCl2, I said we were doing moles of HCl. That is 2 moles of HCl. My problem asks for moles, so I don't need to do any further conversions. So I can go ahead and solve. So for every multiply across the top, divide by the bottom. And when I do that, I get that if I'm just looking at my BaCl2, I can make 12 moles of hydrochloric acid. All right, then we'll take our second given. So my second given is going to be 5.0 moles of H2SO4. And I'm going to solve it the exact same way. So according to my balance, again, I'm already in moles. So I'm just going to go into my mole-to-mole ratio. Don't want moles of H2SO4, so I'm going to go ahead and drop it low. And based on the coefficients of my equation, for every 1 mole of H2SO4, it produces 2 moles of HCl. Moles of HCl is what I wanted, so I'm going to multiply across the top, divide by the bottom, and I end up getting that I can make 10 moles of HCl based on the amount of H2SO4 that I had. So my answer would be that I can make 10 moles of HCl because it's smaller. So that's so then H2SO4 would be my limiting reactant, and BaCl2 would be my excess reactant. So BaCl2 equals excess, and H2SO4 is my limiting reactant. All right. Okay, guys, now that one was just with moles. So our next one is going to involve grams. Okay, let's solve it. If 35.6 grams of zinc are reacted with 100 grams of copper 2 chlorate, how many grams of pure copper will form? Okay, step 1, we got to write our balanced chemical equation. So I have zinc, Zn, plus copper 2 chlorate. So that's going to be CuClO3, 2. And then that looks like a single replacement reaction to me. So again, we don't have to check the thing if we say it happens. You can just assume it's going to happen. So zinc is going to come and kick out that copper. We'll have copper all by itself. And then we'll have zinc with chlorate there. So zinc is a positive 2 charge. chlorate is a -1 charge, so we swap, drop, reduce. I get ZnClO3, 2. And it's all balanced already, so we're good to go. All right, so let's take our 2 givens. I'm going to start with zinc as my first given. So 35.6 grams of zinc. I'm going to zoom in a little bit. And I want to get to copper here. All right, so step 1, convert to moles. I'm in grams of zinc. Grams of zinc is not what I want. So I'm going to drop it low. And then to get to moles, I'm going to use my molar mass from the periodic table. According to my periodic table, the molar mass of zinc is 65.39 grams. And that's going to be equal to 1 mole of zinc. It's just an element, so we can just get its molar mass straight from the periodic table. Now, our next step would be mole-to-mole ratio. I don't want moles of zinc. My end goal is grams of copper. So I'm going to go ahead and do my mole-to-mole ratio to get from zinc to copper. So I'm going to drop moles of zinc low. And I know from my reaction that 1 mole of zinc is equal to or produces 1 mole of copper. Copper's still not what I want, so I'm going to go ahead and drop moles of copper low. My problem asks for grams, so the last thing I'm going to do is I'm going to go ahead and convert to grams. So 1 mole of copper is going to be the molar mass. On my periodic table, it tells me that the molar mass of copper is 63.55 grams. And that's what I want. I want to end up in grams of copper, so I can go ahead and solve. To solve this one, I'm going to multiply all the way across the top and then divide by the product of the bottom. So you guys can go ahead and plug it into your calculators. And when I plugged it in, I got that this would make, we have 3 sig figs in our given, so I should have 3 sig figs in my answer. So I got that it would make 34.6 grams of copper. Okay, now we're going to do it all again with our second given. And our second given is 100 grams of copper chlorate. So set up my thing. And I have 100 grams of copper chlorate. All right. So step 1, get to moles. I don't want grams of copper chlorate, so I'm going to go ahead and drop that low. And I'm going to solve, I need to solve for my molar mass of that. So since it's a compound, I'm going to come write it out. I have copper. I have 1 copper, and according to my periodic table, the mass of copper is 63.55. I have 2 chlorines. I have 2 because it's in parentheses, so that 2 is going to distribute to both of them. And so the molar mass of chlorine is 35.45. And then I have oxygen, 6 oxygens, and each oxygen is going to have a mass of 16. So I'll add all of those together. And when I do, I get that the molar mass would be 230.45 grams per mole. All right, so I'm going to go ahead and plug that in over here. Ooh, I didn't quite leave myself enough room. I'll fix it. $230.45 grams of copper chlorate. And that is equal to 1 mole, because our molar mass is always equal to 1 mole. All right, our next step is our mole-to-mole ratio. So we're going to get from copper chlorate into just pure copper. So I'm going to drop moles of copper chlorate low. And I'm going to use my coefficients from the balanced chemical equation to convert from copper chlorate to just copper. So from my balanced chemical equation, for every 1 mole of copper chlorate, it will make 1 mole of copper. Moles of copper is still not what we want. So we're going to drop it low. And this time we're going to go ahead and convert to what the problem asks for, which is grams of copper. So 1 mole of copper weighs, again, from our periodic table, 63.55 grams. All right, guys. So then that would be how we solve that one. So we would multiply across the top, divide by the product of the bottom to give us our answer. So go ahead and plug it into your calculator. And round for sig figs, it should have 3 sig figs. So when I did that and I plugged it in, I got 27.6 grams of copper. All right, so now we compare our answers and we are going to pick our smallest one. So our smallest one is going to be 27. So that means that zinc is our excess reactant and copper chlorate is our limiting reactant. Okay, so the next thing that you may see is you may be asked how many grams of your excess or limiting reactant will be left over. So in this case, we're asked how many grams of zinc, which is our excess reactant, are going to be left over. So I'm going to go through with you guys how you could solve this one. All right, so first step, and I'm zooming in really small just to make sure I still have room to solve this problem afterwards too. So step 1 is you're going to take the given amount of excess reactant, or of limiting reactant. So take your given amount of limiting reactant. Step 2 is convert it to excess. And that'll tell us how much excess reactant we used. Just convert to excess reactant. That'll tell us how much we used. And then subtract the difference. So subtract your original amount of excess minus amount used. And that'll tell us how much we have left over. So take your given amount of limiting reactant, convert to excess reactant, and then subtract original amount minus amount used. And that'll give us how much we have left over. All right. So let's start this one. So it says how many grams of zinc will be left over. All right. So we're going to start with our original amount of our limiting reactant. So we had 100 grams of copper chlorate. All right, I'm going to go ahead and I'm going to convert that into grams of zinc because that'll tell me how much zinc I needed to react with my copper chlorate. So grams of copper chlorate is not what I want, so I'm going to go ahead and drop it low. All right. And use my molar mass to get to moles. I already saw for it, so I'm just plugging in my molar mass from my previous problem, which is 230.45. And I know that my molar mass is equal to 1 mole of copper chlorate. All right, I want to know how much zinc I use, so I'm going to go ahead and I'm going to convert that to zinc using a mole to mole ratio. So for my balanced coefficients, I know that 1 mole of copper chlorate is equal to 1 mole of zinc because they both have a 1 in front of them, or no coefficient, so it's an assumed 1 to 1 mole of zinc. One more time, I'm going to go ahead and keep converting because I really want to know grams since that's what I know from zinc. So 1 mole of zinc is equal to 65.39 grams of zinc. All right, then I'll multiply across the top and divide by the bottom. Go ahead and plug it on in. We have 3 sig figs in our answer. And so when I plugged it in, I got 28.4 grams of zinc. So this again tells us how much zinc did we use. So this is how much zinc was used. So I'm going to subtract from my original amount. So looking at my previous problem, my original amount of zinc was 35.6 grams of zinc. I used 28.4, so we're going to go ahead and subtract those. So 35.6 grams minus 28.4 grams gives me, go and plug it into your calculator, and it gives me that I should have 7.2 grams of zinc left over. Okay, so that's how we would solve that one. All right, and then last but not least, how many grams of copper 2 sulfate will be left over? Well, guys, this one is our limiting, oh, and this should say copper 2 chlorate. Whoops, I'll make sure I fix that on yours before we give it to y'all. But how many grams of copper 2 chlorate will be left over? It's our limiting reactant, so there should be 0 grams remaining because we always use up all of our limiting reactant.
Good morning, Tyler.
Okay, so we completely use up our limiting reactant. All right, we got one more problem here. I want you guys to go ahead and pause the video and work through it. And then once you're done, come back. It's easy. It's just a nice mole-to-mole one. All right, so go ahead, pause the video, work through it, come back when you're done. Okay, I realize I kind of lied. So it's a mole-to-mass one, not a mole-to-mole one. All right, so step 1, balanced our chemical equation. I got 4, 5, 4, and 6 as our coefficients that we need there. Then we take our two givens and go ahead and convert them into what we're looking for. So we were looking for grams of nitrogen monoxide. So I did my mole-to-mole ratio and then my mole-to-mass ratio. I got 270 grams for the first one, 240 grams for the second one. We always pick our smaller answer, so we would only be able to make 240 grams here. So oxygen would be our limiting reactant, and ammonia would be our excess reactant. All right. Okay, guys, you got plenty of practice down here to work over these different types of problems. I would suggest working a couple of them just to make sure that you understand and are good. All right, as always, email us if you have any questions, and I'll see you guys later. Bye.